the argument of a2I, and I've illustrated it on the Argand diagram. So we know that it has a real value of 3 and an imaginary value equals to a plus bi is my has the coordinates of a, b. What I'm going to do now, and point A and the origin will be point O, magnitude of the ray. The argument of a complex array OP, and I'm going to call the argument theta. Recap. We know that generally any point P, and if you have a distance, look at the distance between A. That distance is A units. And if I looking at trig functions, I know that tan theta is, if I want to calculate theta, it's going to be arc tan, and theta is called the argument of that. Theta equals to the. Now, how do I calculate theta? Theta can be calculated in radian measure. If you're not clear with what radian measure is, you need to know how to convert from degrees to radian measure, or to revise that before you continue with this topic. 80 degrees. Theta, or the argument of n pi. So we say that the equal to pi units, but greater than when we measure in radians. In degrees, it would say that theta to minus 180 degrees. So let's calculate to 3 plus 2i equals to arc tan b over a, going to be arc tan 2. Now I've calculated it on the calculator, making sure I get 0,588 radians. 588, and there's no on how many decimal places you need to round off. Measurement, but for this course we want radian measurement, so radiant measurement. How do you change from degrees to radian? And then you would find radians, and then that's how you get your, must be in radian mode, and in core math we have it in degrees. In example 2, we have the complex number z equals to minus 2, negative 2, 3. And if I want to angle theta from the positive x-axis to the ray, that this is 180 degrees radians. And if I want to calculate theta, it's that little reference angle there. Now, I'm going to calculate is going to be arc, and it's going to be arc tan. It's a positive angle, it's an acute angle, and if you enter the radian mode, you see you're going to get 0,98. What is theta? Theta is going to be pi minus, so it's going to be pi, and so that gives me 2,15 off to 2 decimal places, so it's 2,1. Example 3, z is minus 1 minus 1 minus 4. We usually move anti-clockwise, but because we know that must be less than pi, what we're going to do is we are now going to change direction. Angle theta is going to be measured in a clock, the size of theta. So we know that the reference arc tan b over a, arc tan of the values, because my reference angle must be positive, and 3258. So if I want to get to minus pi radians plus my reference, can be minus pi minus my reference. Calculator, you're going to get minus 1,57 radians. Theta equals to minus pi plus the reference angle. In the last example, the argument theta, and because we're changing direction, arc tan b over a, so let's just do it in this, because we change direction, arc tan of minus arc tan 3, my p coordinate is -1. So it's going to be, and that gives me, get minus 0,321, rounded off to 3 decimal places. So it's going to give me minus 0,3.